Back again, reviewing for your Algebra 1 Semester 1 final exam. Problem 46 is still in our Unit 4, which is Systems of Equations. Again, they've given us two different ways to represent a line. First, they've given us an equation, and second, they've given us a line that's in a table. We know these are both different lines, though, because they told us two linear equations up at the top. And the question is, what is the solution? Of course, as we remember, a solution is where two lines cross or intersect. And there's a couple ways to attack this problem. I'm just going to take you through the few ways that I went through when I was looking for the answer earlier on. The first way I thought to do this was to actually graph both equations. Although there isn't an xy axis provided here, realize that on your test you do actually have about 6 or 8 coordinate planes at the beginning that you can graph anything on. So I'm going to take advantage of that right now. Actually, I think I'm going to use a longer axis too. And the reason I'm using a longer axis is because I know I'm starting at -4, but I need to be able to go at least down 3 over 1. And we'll see if this is going to work. So something like this. So I'll graph the first equation in blue. It starts at -4 and then goes down 3 to the right 1 because we want to have a negative slope. Or you could go up 3 to the left 1. Up 1, 2, 3 to the left 1. Up 1, 2, 3 to the left 1. So we have an equation that looks something like that, except real crooked. So something like that. Better. Alright, and then I'll do the table in green. The table is just a list of points, so I might as well graph all those points and see what happens. We have -1, 4. We have 1, -2, and 2, -5. Oh, -1, 4. That makes more sense. 1, -2, and 2, -. 1, 2, 3, 4, 5. So looking at this, I think I counted that incorrectly. 1, 2, 3, 4, 5 is right here. Looking at this, at first glance, I'm thinking these probably have no solution because they look pretty parallel. But what if I'm a really bad artist? Now, glancing at these, it's definitely not infinitely many solutions. They're not right on top of each other. And it's clearly not either of these either because the lines don't cross at that point. I'm not that bad of an artist, so my guess is it's no solution. But how could we prove it? Well, we can prove it by looking at the slope of each line. We know the slope of my blue line is -3 over 1. Let's find the slope of my table. And to find the slope of a table, let's think about these points, -1, 4, and 1, -2. I'm going to use our slope formula that's given to you in your formula sheet at the beginning of this, and it's just the difference in the y's over the difference in the x's. We need to label these, so we'll maybe call this x1, y1, x2, y2. Just keep your 1's together, your 2's together, and your set. Points always go x, y. So y2 I labeled as -2, y1 was 4, x2 is 1, and x1 is -1. So as I go through and do the math, we get -6 over 2, which is -3. Notice that this slope here is the same as the slope over here. Two lines with the same slope and definitely not on top of each other. That has got to be no solution. They never cross.